My name is Subhasis Maiti. I mainly talk about the lifetime magnetogenesis in presence of ultralight axions and its observational imprint on GW signal. So we already know that our universe is fully magnetized in observable different scales, and there is several ways we can indirectly probe. One of them the CMB anisotropy. It puts the upper limit of the magnetic field around 10 to the minus 9 Gauss, whereas the gamma ray observation actually put the lower limit is around 10 to the minus 18 Gauss. So the question is how this magnetic field are originated. There are several ways of originating this kind of large scale magnetic field. Mostly studies is the inflations, and there is a post-inflationary dynamics. They can also be produced the magnetic field and QCD phase transition, and other there is several ways. Now we always question that whether this magnetic field actually originated in the beginning of the universe, or there is some lifetime dynamics that can actually enhance that such that we can get such huge magnetic field at CMB scales. So here we consider the dark ages era, because we already know during the dark ages photon are freely travels, and if the ultralight axions are present in the background, they can easily couple with the photons or gauge field, and when the axion field are oscillating in the background, they give you the tectonic instability in the system, and they can enhance the magnetic fields. So this is the alpha is the some coupling constant, f is the decay constant of the axion fields, and phi is the axions, and the potential of the axion field typically known, and here m phi is the mass of the axions. When this axion field are oscillating, when the mass of the axion and the background Hubble are comparable, then the axion field are oscillating. When they are oscillating in the FLW background, the system of equation look like this, where you can see this the effective omega term is a negative when this entire quantity is negative, and it is only possible when the axion field are oscillating in the background. And then we have a tectonic instability in the systems. You can see in the this figure we are to plotting the Coulomb magnetic field as if for to this mass 10 to minus 28 electron volts with alpha is equal to 80, and over the time there is a huge enhancement on the background magnetic fields, and it is a corresponding the present observational bound that we can see for this typical mass range. They can generate the magnetic field at 1 megaparsec scale, which are well consistent with the CMB as well as the gamma ray observations. So as there is a huge amount of production of magnetic field during these times, obviously they can produce significant gravitational background during these times. So obviously this is a well known equations. This is the source by the electromagnetic field during this era. Okay, so if we solve the equation numerically, they typically proportional to the b to the 4 well known, and you can see that with this mass range in the CMB's length scale, CMB observational length scale, they can produce the significant gravitational wave with the multiple peaks, and in this type of magnetic scenario actually generate the helical magnetic fields. So obviously we should expect the gravitational wave that produce, they are also be helical in nature. So in future CMB observations, like if we detect the beam mode polarization, then they can be probed as well the magnetogenesis scenario, and can be constrained the mass of the axion if they are present during these times. So this is actually mainly the outcome of my talk. So yes, the ultralight axions with a mass 10 to minus 31 to 10 to minus 27 electron volts with the coupling strength with this 17 to 80, then they can generate the huge amount of magnetic field at CMB scales. This is one of the alternative way of generating the large scale magnetic field, obviously, and obviously they can generate the significant gravitational wave background, and maybe they can be detected by beam mode polarization in futures. So this is, I think, the outcome of my talk, and thank you for
Thank you so much for facing very time.
Yeah.
Okay, so maybe we have 1.5 minutes for questions and comments. Okay. You think of producing an ALP field by breaking one additional U1 symmetry in the early universe. That's how you propose this kind of coupling. So how will the spectrum of the electric or the magnetic field in this scenario depend on the energy scale where the additional U1 symmetry is broken to produce the ALP? The
And
spectrum
scale-
today strongly depends on the Hubble scale during inflation.
Yes,
The
yes.
question I'm asking is that how will the spectrum or the strength today will depend on the scale where you break the additional U1 symmetry to produce the ALP.
It is very actually late, I think. The mass is very small. So
So during what epoch are you breaking the U1 to produce the ALP?
I think electroweak symmetry breaking this low mass, you can.
Sriram has some questions.
What I'm asking is related to what Rajiv is asking. When are the magnetic fields produced?
Up during dark ages, actually they are again excited because of the
Dark ages means you're talking about, below redshift of 1000.
Yes, yes,
They are generated on large scales
Yes.
at that time.
yes. Because of the background axion, that if this low mass axion are oscillating,
But what are the initial conditions on the electromagnetic fields?
yeah, they can be generated from this inflationary fluctuations. Even if we consider they have some power law, k to the power 3 power law. With
You're
some
assuming something at early times which is
obviously there
evolving now.
Yes, yes, yes. They are already presented some amount, but this strength is very low because they are
They are amplified at
Yes.
this time.
We are amplified at later time. Kinetic energy converted to the magnetic field kind of.
So axion field is decaying into magnetic field.
Yeah.
Is that?
Yeah, kind.
Any other questions? So, Subhash, just a small question. I mean, because you want it to rather enhance during the dark ages, so do you need to do any kind of fine tuning for that? Because
No, I think we don't need to do any fine tuning. The mass is very important. Like obviously there is a particular mass range they are oscillating during dark ages. This is the fine tuning parameters, and alpha is the p parameter you can choose accordingly.